Okay, we are recording, and let me share the screen. So we talked about yesterday 3 situations with circles and secants and tangents. So let me draw 3 circles. Okay. So we said if the angle is on the inside. So here we have 2 chords. Okay. And they're chords because they are, the endpoints are on the circle. If I want to find the measurement of this angle, okay, it'd be 1/2 the sum of the chords. So let's say this is chord A, chord B. So the formula for the angle measure is 1/2 the sum of chord A plus chord B. Okay, and that's if the angle is formed on the inside. The next situation we can have is if we have a secant or a chord and a tangent, and they intersect at the point of tangency. And so this is on this, the angle is on the side of the circle, okay? So instead of being on the inside, the angle is on the side of the circle. And in order to find the measurement of this angle, angle 2, it'd be 1/2 the intersected chord. So let's call this C. So the formula for this angle on the side is 1/2 the chord. Okay. And the third scenario that we can have is if we have a 2 secants or 2 tangents, or a secant and a tangent, and the angle is located on the outside. So this angle right here. So we say that this is an angle on the outside of the circle. And if you want to find that angle, the measurement of the angle is 1/2 the difference in the big arc minus the small arc. So let's say this is arc D, and this is arc, say, E. Okay. So the formula for an angle on the outside is 1/2 the big arc, which in this diagram is D, minus the small arc. Okay. And so those are the situations we can have with angles and angles formed by chords and tangents. So the angle can be inside, on the side, or on the outside. Okay. Any questions about these and any problems associated with these? All right. Now, let's talk about special line segments. Formed by the intersection of angles, formed by the intersection of secants and tangents and stuff like that. And by and far, this section will be the most complicated that you'll have, that we're going to talk about right now. And it's called special segments. Okay, special segments. Okay, So let's take a scenario like this, okay? Scenario 1, we have two chords intersecting in the middle. We know how to find the angle E if need be. It would be 1/2 the sum of the two arcs, AD plus BC. But that's not what we're looking for. Say, for example, we're looking for the relationship between these pieces or these line segments, AE and EC versus BE and ED, okay? So when you have two chords intersecting on the inside, it forms four separate line segments, AE, EC, BE, and BD. I mean ED, sorry. So what this theorem says is that the relationship between these four line segments is this. If you take line segment AE and multiply it with its adjacent line segment, which is EC, it equals line segment BE times ED, okay? And that's your relationship. Now, because of this relationship, you're going to get a lot of equations that are quadratic in nature, all right? So you may need to solve via factoring or solve using the quadratic formula. So here's a simple example. Find x. So we're going to use the relationship that we learned about these four line segments to find x. And the relationship is that this piece right here, AE, multiplied by the piece adjacent to it, which is 6, is equal to this piece right here, which is CE, multiplied by its adjacent segment, which is 4. Now, where a lot of people make mistakes here is that they add these adjacent segments and not multiply. But the relationship is one in which you have to multiply them, okay? So 6 times x, which is 6x, equals 3 times 4. Okay. So when we solve this, we get 6x equals 12. So x equals 2. All right. Now, let's look at this right here, this diagram. Again, we're asked to solve x, which is this long piece right here. And the relationship is the long piece times the piece adjacent to it, multiplied together, is equal to this piece, which is 24, times the piece adjacent to it. Okay. So when you solve for x, you get 48. Okay. So you plug that into your calculator, 24 times 24, then you divide that by 12, and you should get 48. Okay. Now remember, do not forget that if you have a circle, okay, with a chord and a diameter perpendicular to that chord, that it bisects that chord, okay? So in a problem like this, the way they might do it is instead of giving you that each piece is 24, what they may say is, okay, you got a circle, here's the diagram, this piece is 12, this piece is x, and this chord is 48. Solve for x. And that means that you have to remember that when a chord is perpendicular to the diameter or to the radius, it cuts that chord in half. So each piece is 24. And then you do exactly what we did. All right. Okay, so let's talk about this scenario. So the first scenario was when we had the segments on the inside of the circle. Now we're talking about segments that are on the outside of the circle. So we know how to find the angle. This angle is 1/2 the difference of the big arc minus the small arc, okay? But that's not what what I need to find. I want to find the relationship of this piece to this piece. And the relationship is the piece to the circle multiplied by the entire segment is equal to the piece to the circle times the entire segment. So AB times AC equals AE times ED. Okay. So when you have segments coming out from the outside, it's the line to the circle times the entire line equals the line to the circle times the entire line. Okay. So here's a problem type that we may be asked to solve. So find RS, so this is what we're looking for, given this diagram. So the relationship is, remember, the piece to the circle times the entire piece multiplied together is equal to the piece to the circle times the entire piece. So QR times QP, not QP, sorry. QR times RP equals RS times RT. So in this diagram, QR is 2, RP is 2 plus 12, which is 14. RS is X, and RT is X plus 3. So it's X times X plus 3 equals 28. So when you solve this, you first have to distribute the X. And so remember, this is a quadratic equation, okay? And when we solve a quadratic, we have to have one side equal 0. So we move the 28 to the opposite side, so one side can equal 0. And the way we solve it is by factoring. So if you need a crash course in factoring because you won't be able to do the problems otherwise, you may want to either set a tutoring session time with me, or you can watch some of the Algebra 1 videos that I've uploaded to YouTube as well. Okay. Now, when you factor, you set each one of these smaller binomials equal to 0 and solve. Okay. Now remember, this is geometry, so my answer, my line segment can't be negative. However, when I solve this equation, one of the answers that I got for X, which is this piece right here, is -7. I can't have a line segment that's -7. So the only answer that can work is 4. Okay. So you may have a scenario where both answers work. You may have a scenario where only one answer works. Okay. So remember, with geometry, we can't have negative line segments. All right, so let's do a couple of example problems. Let's do number 4 and number 6. Let's have you guys do number 4 and number 6.
Is x equals 2? Number 4.
Hey, how'd you do it?
9 times x and equals 3 times 6.
9 times x equals 3 times 6. Okay. So if it's inside, it's piece times piece equals piece times piece. So 9 times x equals 3 times 6, and you can solve. Mr. Caleb, do you have an answer for number 6 yet?
No, just give me a minute.
All right.
Do we do it the same
Mhm.
way we did the first one, number 4?
No, remember it's on the outside. So it's piece to the circle times the entire segment equals piece to the circle times the entire segment. So it's piece to the circle, which is x, times the entire segment, which is x plus 10, equals piece to the circle, which is 3, times the entire segment, which is 8. Now, let's talk about number 6. So remember, this is quadratic in nature. So we have to solve this. So that, remember, when you solve a quadratic equation, the first thing you got to try is to see if you can factor it. Are there factors of -24 that combine or add to give you positive 10? So if you look at the factors of -24, it's -1 and 24. What else? -3 and 8, -4 and 6, -2 and 12. Okay. So if you add them, you get 23, 5, 2, and 10. So the one that we're going to use is the last one, because they multiply to give me 24, and they add to give me 10. And when you solve, you get x equals -12 and x equals 2. Now, remember, we have to eliminate one of these because one of them is not a viable solution. Okay. Which one do we have to omit? Anyone? All right, the one we will omit is -12 because remember, x is a line segment and it can't be negative. So the only answer that works is 2. All right, let's look at the last relationship. Okay. And this is probably the most complicated one that we're going to be dealing with. And it is when we have outside, but we don't have a secant and we don't have two secants. We have a secant and a tangent. And the relationship is the piece to the circle times the entire piece equals the piece to the circle times the piece to the circle. So WZ times WY equals WX times WX, right? So let's go over the three relationship types that we've talked about. Okay, so the first one is if we have inside the circle. Okay. Now, if it's on the inside, it's piece times piece equals piece times piece. So this times this equals this times this. So AB times BC equals DB times the piece adjacent to it, which is BE. That's if you have the inside. Now, outside, if we have two secants, so outside two secants, okay, it's piece to the circle times the entire piece equals piece to the circle times the entire piece. So AB times AC equals AD times AE. All right. Now, the last relationship is this one right here. It's outside, but it's outside, but it is tangent and secant. And it is piece to the circle times the entire piece equals tangent squared, or tangent times tangent. So these are the three relationships that you need to know when it comes to line segments, right? So that may mean that you may have to memorize these as well. Any questions so far?
Not yet.
All right. So let's look at a couple of problems. So let's look at this one right here. So this is tangent times secant. So remember, it is piece to the circle times the entire piece. So piece to the circle is x. The entire piece is x plus 2, which is 2x plus 2. equals, now the tangent, remember, it is tangent times tangent, or tangent squared. So when you want to solve this, you get 2x squared plus 2x equals 16. Move everything to one side so the other side equals 0, so you can factor. Remember, the first thing that you look for before you factor is any greatest common factor. And in this case, you do. Everything is divisible by 2. And then you factor. Two numbers that multiply to give me -8, but add to give me +1. Okay, so are there any numbers that multiply to give me -8, but add to give me +1? So remember, my factors are 1 and -8, 8 and -1, and 4 and -2, and and +2, -4. And none of these add to give me -1. So in order to solve this, we need to do the quadratic formula. So remember what the quadratic formula is. -b plus or minus the square root of b squared minus 4ac over 2a. Now, what I'm going to do is, just to make this your life a lot easier, I'm not going to give you any problems that are not factorable. So you won't have to worry about problems like this, because I think you guys have a lot on your plate. We can do the quadratic formula, but I just don't see the point of doing it. If I was in class, then I would definitely walk you through this. So let's just do another one that we can factor. Let's do this one, number 12. Okay. So piece to the circle times the entire piece, which is 12, equals tangent squared. So x squared equals 36. X is equal to 6. So remember, this is tangent, so tangent times tangent equals piece to the circle times the entire line segment, which is 3 plus 9, which gave me 12. Okay. Let's look at number 9. So let's try number 9. So the first thing you want to do is look at the line segments that you're given and find out which relationship you're going to use, okay? So work on number 9. I'll be back in a second. All right. So remember, this is on the inside. So we're going to use this relationship. Piece times next piece next to it equals piece times piece next to it. So piece times piece next to it is 9x equals piece times piece next to it, which is 6. So x equals 4. So the good thing is, like, the good thing about having this stuff on Edgenuity that you would not have had the benefit of during class is that these are one-off problems. If you're going to be taking the SAT and ACT, they ask quite a few of these types of questions. But if you're not going towards the ACT, SAT, then most of the time these types of questions are like formulas that you may have to look up. So if it was in class, then I would have asked you to memorize these relationships. But with Edgenuity, you can go back and write down all these relationships that we've talked about yesterday and today. So the relationship with the angles and the relationship with these line segments, and then use whichever diagram accordingly. Okay. So I know I went through that pretty fast, but this is this is basically look at the formula, look at the relationship that you have based on the diagram and solve. And the difficulty will be actually trying to solve the quadratic equation. And if you need any help solving quadratic equations, let me know and I can definitely walk you through it on a one-on-one session. But other than that, this pretty much is the end of circles. So not tomorrow, but next week, by the end of next week, you will have to complete the circles test. So by Friday of next week, you need to complete all the circles test, okay? Because I got to put in grades, and some of you have already done it. But if I do not have everyone done by the circles test next week, whoever does not complete it will get zeros for the circles test. And it is a major grade. So the entire unit must be done by Friday of next week. And the grades will go in as you complete it. If you're not done by Friday of next week, you will be getting zeros for that. So you try to avoid, getting that. So keep up with your assignments. Any questions? If you have any technological issues, let me know. There is a known issue going around because so many people are logging on to Edgenuity. So sometimes the servers are overwhelmed. So if you are having a hard time logging in or moving forward, maybe you may have to reset your computer or come back in half an hour. If it doesn't resolve, reach out to me and I'll try to see what I can do. Tomorrow I have a doctor's appointment, so we will not have lecture tomorrow. However, if you want to have a tutoring session tomorrow with me, send me a message via Remind and we can do some problem types if you'd like. Okay. Any questions? Okay. So if there's no questions, I will we'll end this discussion and this lecture, and then I will see.
I have a question.
Sure. Go ahead.
Yeah.
Mr. Caleb, what's your question?
Oh, my due date is on May the 2nd,
Yeah.
not the 15th. And it's telling me like I'm way behind.
Don't pay attention. Do not give no credence to or any importance to what Edgenuity is
So
telling
I don't know
you.
what to do about that.
You don't have to. You don't have to worry about it. That's something on my end, but you don't have to worry about what it tells you. Just keep up with your information. That's all. Per my calendar that I gave you. Don't worry about what Edgenuity is flagging you that you're way behind or you're way ahead. That's not important. Does that answer your question?
All right.
All right.
Yeah.
Okay, cool.
Thank
So
you.
if you need any more assistance, let me know. Again, tomorrow we will not have class because I will be in the doctor's office pretty much all day. But if you want to tutor, I can tutor in the afternoon if you want to go over problem types. And Monday and Tuesday we'll go over circles. We'll do like a quick review of everything. And hopefully by Monday or Tuesday, most of you actually have done all of the circles and have actually taken the unit test. And remember, you will be allowed one retake for the unit test. So if you don't do well or fail it, you have another opportunity to do well on it. But if you end up failing both retakes, that's the grade that sticks, okay? That's the grade that sticks. And this is a major grade. The unit test is a major grade. So please take it seriously. The advantage is that you can use your notes. You can use your book if you have it. So it is kind of like an open book test. So I am almost begging you guys to make sure you take it seriously and you don't end up failing it, because otherwise that's the grade I got to put in and that may not go so well with you. All right. If you have any questions, reach out to me. And if not, I will see you guys on Monday. All right. Have a great weekend.